All right, pre-algebra Panthers, let's do this. We are going to attempt an online lesson. We're going to start off with a review of something that we've covered in the past, just to kind of help us ease us into the swing of things. Before we begin, though, I want to let you guys know that those of you who help spread the word of what we're doing over the next few weeks and help people get signed up for Google Classroom and just, for even entertaining the idea of, staying up to date with your work and going through and trying some online work with us. I cannot tell you how much I appreciate it. Miss Stevens, Mr. Baca, and Miss Laux feel the exact same way, and we we truly are lucky to have you all on the team. And we're doing this because we don't want you guys to lose out on a few weeks worth of instruction. I mean, if you if we end up missing, just the next 2 weeks, that's 10 days or 10 hours basically worth of content that you'll be expected to know next year in ninth grade. And missing out on that will just make ninth grade more challenging than it needs to be. So we're going to hopefully make up for it with these online instructional videos. Please let me know if there's any changes that you would like to see made. Maybe more examples, or if my mic is too far away and you can barely hear me. I will re-record it if it turns out that, I can't even hear myself when I'm going back and editing it. But just let me know. I'm figuring this out as I go along, and your guys' help will make it go by that much faster. So, whenever we go over a problem in one of these videos, if you think you've got it figured out and you know how to do it, feel free to pause the video at any point and give it a shot, and then you can fast forward to the reveal of the answer, and if you got it, then fantastic. You probably don't need the explanation. But if you get stuck along the way, or if you get it wrong, then, or if you don't know how to begin, then the explanations will be there for your benefit. All right, let's go ahead and get started with this bell ringer, okay, or just, I guess we'll just call it a warm-up problem now. So use the Pythagorean theorem to find the length of the missing sides below. Okay, so just a quick reminder, the Pythagorean theorem, a squared. I'm also writing using the mouse. I do not have a touchpad or the benefit of writing on a Promethean board as I record this. Okay, so a squared plus b squared is c squared. And let's start with this triangle right here. Okay, so right here I can tell that this is our right angle in our triangle, and that must mean that these two sides right here, okay, so these two sides right here must be the legs, which means that we are going to plug 4 and 8 in for A and B. I'm going to go ahead and plug 8 in for A, and I'll plug 4 in for B, but you don't have to. Okay, and all of that is going to be equal to c squared. And remember, side length c is always, always, always our hypotenuse. Okay, so that means that the hypotenuse is our missing side and is the side that we are going to be solving for. So we'll keep that as c squared. Okay, we've got all of our side lengths plugged in, and now we can actually use the Pythagorean theorem. So 8 squared gives us 64, plus 4 squared, which is 16. And that's going to continue to be equal to c squared. Okay, we're going to call it c until we figure out what that side length is. Okay, we're going to add both of these together now. So 64 plus 16 will give us 80 is equal to c squared. And at this point, we are almost finished. Um, we know what c squared is equal to. Okay, c to the power of 2 is equal to 80. But we don't care what c squared equals. We want to know what just regular c without an exponent equals. Okay, so what we're going to do is, to cancel out that exponent of 2, we're going to take the square root of both sides. And that's going to cancel out. The square root and the power of 2 are going to cancel each other out. And that's going to give us c equals the square root of 80. 80 is not on our list of perfect squares, so we're just going to leave that as the square root of 80. Because remember, the square root of a number that is not a perfect square gives us an irrational number. Okay, a number with a never-ending decimal and no repeating pattern. Okay, so rather than writing something that has no end or repeating pattern, we'll just call it c is equal to the square root of 80. And there we go. That is one problem in the books. And now let me erase this. There we go. And we'll move on to this triangle over here. And I'll kind of do the exact same thing, maybe just a little bit faster. So we have our legs right here. Remember, the legs are the two sides that have the 90-degree angle. And then right here, the side across from the right angle, okay, or opposite the right angle, is our hypotenuse. Okay, and remember, the trick is if you draw a diagonal line going through that box that means that this is a right angle, it gives you an arrow that points to the hypotenuse. Okay. So this time we know what c is equal to, and we are solving for one of the legs. So we need to make sure that when we plug this in, that 13 gets plugged in for c. Okay. C squared is always the hypotenuse. Okay, and then I'm going to plug in our 5. I'm going to plug in our 5 right here. So 5 squared plus, and then we'll just call this, we'll call that a. So a squared, or a is going to be the side that we're solving for. Okay, 13 squared is 169. 5 squared, 25. Okay, and then we get a squared. Next, before we can take the square root of both sides to get rid of that a squared, we have to get a squared by itself. So we have to cancel out this positive 25 by subtracting 25 from both sides. That's going to cancel this out. Okay, that cancels out. And then we get a squared equals 169 minus 25 is 144. And now that a squared is by itself, we are ready to take the square root of both sides. The square root and the exponent of 2 cancel each other out. So we get a equals the square root of 144. 144 is a perfect square. So the square root of 144 is 12. So a is equal to 12. And there we go. We've used the Pythagorean theorem to find a missing leg and a missing hypotenuse. Now, before we review the rest of our content about triangles, I want to make a couple of things clear because there was some confusion last week about what the Pythagorean theorem had to do with 180 degrees being the sum of all three angles in a triangle. The answer is nothing, okay, other than, the fact that, both of these have to do with triangles. That's really where the comparisons end, okay? So when you are using the Pythagorean theorem, you are not worrying about 180-degree angle. You're not worrying about the degrees or the angles at all. Okay, you are purely focused on side length. Okay, okay, it deals with side lengths only, and it works with right triangles only. Okay. Now, the other assignment we did, okay, where we talked about how all three angles inside a triangle add up to 180 degrees, that is something completely different from Pythagorean theorem. Okay. Um, so the three angles of any triangle, okay, it doesn't matter if it's right, doesn't matter if it's isosceles, if it's acute, obtuse, equilateral, whatever. Okay, it has nothing to do with Pythagorean theorem, and it works for every triangle. Okay, so these are two very different skills. Okay, and as I just mentioned, and as we reviewed last week, okay, when you add all three angles of a triangle together, you will always get a total of exactly 180 degrees. Okay, so I know when we look here at this triangle here, I know this angle is 33, this angle is 65, this angle is missing, so we'll go ahead and call it, I don't know, we can call it whatever we want. Let's call it Z, just to be different. Okay, and I know that when I add 33, okay, which is this angle here, plus 65, which is this angle here, and angle Z, I know when I add all three of those together, it's going to equal exactly 180 degrees. And what we have here, ladies and gentlemen, is a one-step equation. Kind of, well, maybe a two-step equation, because if I look right here, I see we have two like terms that we can combine together. Let's go ahead and add these together. So if I add 33 and 65, that's going to give me 98. Okay, so we just combined those together into one term. And then we bring down our plus Z equals 180 degrees. And now, if we subtract 98 from both sides, we'll know what angle Z is equal to. Okay, because this 98 degrees is positive, we're going to subtract it from both sides. And that means it's going to cancel out over here. And we have Z equals 180, okay, minus 98. So let's borrow. Okay, so that's going to give me 2. I'm going to have to borrow again. That's going to give me 8. So Z is equal to 82 degrees. Okay, we did not use Pythagorean theorem to get there. We just used a rule in geometry which states that all three angles in a triangle equal exactly 180 degrees. Okay, so add those two together, subtract it from 180, and what's left over has to be what your missing angle is equal to. Okay, I believe I've got one of those pulled up. I was listening to Animal Crossing music earlier. Here we go. Let's do one of these. Let's do one more of these things together. And oops. Let's zoom in a bit. There we go. So find the value of x in the triangle shown below. Okay, so I know that when I add this angle, and this angle together, that it's going to total exactly 180 degrees. Oops. That's a bit much. Okay, so it went outside the lines, but that's okay. Okay, so I know when I add all three of these angles together, it's going to total 180 degrees. So 45 plus 98 plus x, right? So plus x. Ooh, that's hard to see. Okay, I'll write it in black, but I will highlight it in yellow so that you know where it came from. Okay, let's combine our like terms right here. So that would be what? 98 plus 45, so that would be 3, add the 1, so that would be 143. And then plus our x equals 180. And now, to get x all by itself, on the left side of the equal sign, we have to cancel out that 143. So because it's a positive 143, I'm going to subtract it from both sides. That's going to end up canceling it out over here on the left. Okay, so it cancels out. And then we get x is equal to 180 minus 43. So let's go ahead and borrow. We'll do that. That's going to give us 7, and that's going to give us a 3. So 37 degrees. Okay, we'll go ahead and type this in here. See if it's correct. It is. Hooray. Okay. And there we go. We've done it. Oh, I just shifted everything off screen. So, again, today was meant to be mostly a review. Tomorrow I will do a review of the isosceles triangles thing. Okay, figuring out which two angles are the base angles and which one is the third that doesn't match. I will go over all of that again tomorrow. I'm going to hopefully upload as many as 2 to 3 videos a week. They take a while to put together because I have to write the notes, write the script, write the examples, record it all, hope that the microphone works all the way through, and deal with my own shortcomings as a video producer. So just bear with me here. But again, send feedback, in the posts on Google Classroom with the video link in them. And we'll learn through this. Well, we'll get through this whole thing together. So, again, thank you for dedicating some time to practicing math and science and language arts and social studies. I know that you could very easily have ignored the emails we sent. And I want you all to know that you will be getting credit for this, and I promise you all, we will come up with a way to reward those of you who are going through this with us when we come back, hopefully sometime in April. All right, take care, you guys. I'll talk to you soon.